let's take a look at this interesting problem. There is also inequality. You just have to be very careful how you deal with this. You have a new restaurant in Atlanta that charges customers about how much they consume by measuring their weight before and after they eat. It's a very interesting concept. Uh, but the trick is the scale that they use to measure is also faulty. It is accurate to 1%. And suppose John entered the restaurant with a weight of 140 pounds and came out with a weight of 145 pounds. Uh, and they charge 349 per pound. Which of the following will be a potential bill that John will pay? So here, the most important thing is to look at the various things. They told you that, this is, you're going to assume this is weight. So uh, John is going to pay by weight. So we're going to represent uh, John's weight with simple thing like W. All right. So let's say John's weight is W. Not John's weight. Technically, you can represent John's weight by W, but how much John ate can be W. The food he ate will be W. If he ate W, then obviously W will be W plus or minus 1% of W. You see, because the scale is up by 1%. So whatever John eats, he's going to have to deal with 1%. 1% is 0.01. So we're going to look at this plus or minus 0.01 of whatever John ate. That is the basis of this problem. And that is why it is not a single number. Technically, you have the number ranging. It's an inequality problem. It's ranging between two different distinct values. So right now, we know for sure that John went in at 140 pounds, came at 145 pounds. But we know John's weight as measured by the system is wrong before and after. So at least we can tell that John uh, ate something like 5.5 pounds, but that 5.5 pound is off by 0.01 of 5.5 pounds, right? Do you see that? So 145.5 minus 140 is 5.5 pounds. If the scale is fine, then we will multiply 5.5 by 3.49. But the scale is wrong by that, so we need to calculate this range. So that means we're going to have 5.5 uh, uh, minus 5.5 times 0.01. That is the lower level. And then the upper level will be 5.5 plus 5.5 times 0.01. So let's find out. So that will be the range. So this is the lower amount and this is the upper amount. So let's find the values and apply. So let's bring our little calculator here and do our calculation. So we're going to do 5.5 times 0.01. So this is what, so obviously then our system is going to look like our range of values will be 5.5 plus or minus, what did we get? Let's bring our calculator here. I think we got 0.055 plus or minus 0.055. That's what we got. So that means the lower value will be, well, let's put the scale here. So we're going to put our scale back here, and that will be equal to 5.445, and the upper value will be 5.555. So this is what the scale will tell. Now this will be the lower scale, this will be the upper scale. So any amount between this area here will satisfy. So when we take 5.445 and multiply to 3.49, we will get 19.003, and then when we take this, we will get 19.38. So any amount that falls within this range will satisfy the requirement that we want. And if you look at your answer choices, obviously A is wrong, B is 19.1, and that's something to be fall in there. 19.5 is outside the range, 20 is outside the range, so your answer choice is B. So this is the only choice that satisfies this inequality. All right. So hope you get this basic logic correct. So review this, and and then put some questions if you still want to understand it more. All right.